Hey boys and girls, I wanted to jump on here and quickly do a video on how to plot polar graphs, polar coordinates, especially when you have negative angles and negative R values. I was teaching this morning in First Block and had somewhat of a little bit of a brain fart, so please forgive me. So basically what you want to do, you want to start with the angle. So we want to go to angle 3 pi over 4. So 3 pi over 4, this is 1 pi over 4. So 3 pi over 4 is here. This is the line for 3 pi over 4. And normally if it had been a positive one, we would have just stuck it right there. But since it's a negative one, it's going to flip over the axis and therefore it becomes there. So that is the graph of negative 1, 3 pi over 4. So what I've learned in doing this is that it's better to start with the angle. So like in the next one, we're doing negative 2 pi over 3. So negative 2 pi over 3 would be, this is negative pi over 3. So negative 2 pi over 3 is here. So this angle is negative 2 pi over 3. So if this, again, were a regular 2 would just go here. But since it's negative 2, then it's going to pop and go to pi over 3 on the positive side. Okay, so does that make sense? I hope it does. Let's do a couple of more. Okay, so for 5 pi over 12 is somewhere between 7 pi over 6 and pi. So pi over 12 is somewhere, well, normally pi over 12 would be somewhere between 0 and pi over 6. And so if we were going to do 4, it would be here, but since we're doing negative 4, it's going to come and be here. Okay? So you start with the angle, you find the angle, and then you do the radius. So negative 7 pi over 6, negative 7 pi over 6, this is 7 pi over 6, so negative 7 pi over 6, we would go all around back to the first quadrant to pi over 6. And then at pi over 6, if this had been just 4, we would do it here. So if this had been 4, negative 7 pi over 6, that would be here. But since it's negative 4, negative 7 pi over 6, now we go here. Oh, sorry, I took the wrong one. We go there. Okay, because this is negative 7 pi over 6. If we go all around we come here. This is negative 7 pi over 6. And this would be 4, negative 7 pi over 6. But if I want negative 4, 7 pi over 6, I have to come here. So this is negative 4, negative 7 pi over 6. Okay? I hope that makes sense. And if not, we can do some more in class. All right. Converting each polar coordinate to rectangular coordinates require this is polar to rectangular. So that requires that we remember that x is equal to r cosine theta and y is equal to r sine theta. So we have r is 4, so this is going to be 4 cosine negative pi over 4. And what I kind of told my students today was that I start with negative pi over 4 since this is in the unit circle. I know that negative pi over 4 is here. And so this is in the fourth quadrant. So cosine is positive and sine is negative. So this is going to be 4 times the cosine of radical 2 over 2. And this would be 4 times the sine of radical 2 over 2. And I knew when I said that was wrong. I was thinking ahead of myself. This is cosine of negative pi over 4. And this is sine of negative pi over 4. So the cosine of negative pi over 4 is radical 2 over 2. So this would be 4 over 2 radical 2. And this would be 4 over negative 2 radical 2. So my points are going to be 2 radical 2, comma, negative 2 radical 2. Okay. Again, I keep having brain farts on these. Today I kept saying tan was x over y when I know for a fact tan is y over x. And so for the next one, we have negative 1 over negative 11 pi over 6. Once again, I'm going to use the unit circle. This is positive pi over 6, so negative pi over 6. This would be negative pi over 6. This would be negative 5 pi over 6. So this would be negative 7 pi over 6 would be here. Is that right? No. This is pi over 6. This is 5 pi over 6. This is 7 pi over 6. So this is negative 11 pi over 6 here. So again, I recognize that my both the cosine and the sine are going to be positive. So we're going to get radical 3 over 2 and 1/2. And since I'm multiplying that by negative 1, this will be negative 1 times the cosine of negative 11 pi over 6 and negative 1 cosine. What is wrong with me? Sine of negative 11 pi over 6. And so knowing that that's in the first quadrant, I can say that this is going to be negative 1 times radical 3 over 2 and negative 1 times 1/2. And those are my coordinates. I thought I was going to have to use some extra paper. I did not. Now we're going to convert from rectangular to polar. So we have to use the same concept. So we're converting each pair of rectangulars. So these are x and y values. And I want to take them to r and theta values. So the first thing I have to do is find r. So r is going to equal to, r squared equals to x squared plus y squared. So r squared is equal to 3 squared plus 0, which r squared is equal to 9. So r is equal to 3. And then to find my angle, I have to remember that tangent of theta is equal to y over x. So that means theta is going to equal to 0 over 3. And you know that's wrong. Theta equals to the tan inverse of 0 over 3, of y over x. So the tan inverse of 0 over 3 is 0. So that means that my r is 3 and my theta, so I'm going to write this as r theta. So r is 3 and so is theta. Now a couple of people ask, well, how do you know theta is not pi? And I know that because x is 3, so that's in the first quadrant. If it were pi, then x would have equaled to negative 3. Okay, same thing for here. We're going to start off by saying this is an x value and this is a y value. So we have r squared is equal to negative square root of 2 squared plus the square root of 2 over 2 squared. So r squared is equal to 2, that would be 2 over 4, so 1/2 plus 1/2. So r squared is equal to 1, which makes r equal to 1. And then to find my angle, I'm going to do the tangent theta is equal to y over x. So that's radical 2 over 2 over negative radical 2 over 2. So I get the tan inverse, I get theta is equal to the tan inverse of 1, negative 1. So what quadrant is that in? Well, my x value is negative and my y value is positive, so that tells me that that's in the second quadrant. So tan inverse of 1 in the second quadrant is one of my pi's over 4, so that would be 3 pi over 4. So my value would be r would be 1 and theta would be 3 pi over 4. And that would be the polar coordinate. Okay? And then now we're going to convert. So to convert, let me get a new page here. So to convert, we have to remember several equations. One is x squared plus y squared equals r squared. We need to remember that x is equal to r cosine theta. Y is equal to r sine theta, excuse me. And tangent of theta is y over x. These four formulas you need to memorize and know. And you're going to need them as we go back and forth from one to the other. All right, so let's start by looking at y equals 5x. Well, I know that x, because when I'm doing this, what I want to do is I want to get rid of my x and my y's. Okay? So y is r sine theta. 5x would be 5r cosine theta. So I define them. So let us see if we can't solve for r. Well, if I do, I see that my r's are going to cancel out. So I'm going to divide both sides by a cosine theta, r cosine theta. So when I do that, the r's cancel, and I'm left with sine theta over cosine theta equals 5. And that's just 5 is equal to tangent theta. And I've gotten rid of my x's and my y's. So that's my answer. All right, for the next one, this one was a little fun to do in class. We have y is equal to x squared over 5. So again, I'm going to change y to r sine theta. I'm going to change x to r squared sine squared theta. No, I'm not. R squared cosine squared theta over 5. So again, I want to get rid of I want to solve for r. I want to put everything in terms of r. Not r squared, just r if possible. So could I divide this side by r sine theta? When I do that, I get 1/5 of r. Let's do, I don't want to do that. What I want to do is I want to divide both sides by cosine squared theta. Apparently I want to do that too. So r cosine squared theta over 5. So let's multiply both sides by 5. Then let's divide by r cosine squared theta, because if I divide by r cosine squared theta, I'm left with r. So if I divide by r cosine squared theta, the r's cancel, and I have 5 sine theta over cosine squared theta, and that's equal to r. And if you wanted to make that look prettier, we can say that this is 5 tan theta times 1 over cosine theta, which is secant theta. And that's equal to r. Okay? Alrighty. And let's try, what do we want to do next? We want to go the other way around. We want to convert we want to convert from polar to rectangular. That's always fun. So let's convert from polar to rectangle. So we have Problem number 21. We have r is equal to tan theta secant theta. Okay, so now remember we're trying to go to x and y's. So what do we know? We know that tan theta is x over y. We know that. We know that we don't know anything about secant, but we do know secant is 1 over cosine theta. We do know that. And so we know that x is equal to r cosine theta. So if I want to solve for 1 over cosine, so if I divide both sides by cosine, I know that x over cosine theta is equal to r, which means that 1 over cosine theta, getting rid of the x, would be r over x. So I can change this secant theta, which is 1 over cosine, I can change that to r over x. Oh, I know what I did. I keep doing this. I told you I was doing this earlier. Tan is y over x. I don't know what is wrong with my brain. Y'all need to pray for me. Okay, so we get r is equal then to y times r over x squared. So what do we do with this? Okay, we were trying to get rid of the r's. So I can divide by r. And then multiply by x squared, and I can get x squared is equal to y. And that's my answer. I know it took a little bit to get there, and you may be thinking, well, I could have done that in fewer moves. Go for it. As long as your moves are legitimate, go for it. All right, last one, 23. Okay, welcome back. Sorry about that. This is not what I did earlier, but I was thinking we could do this. We could multiply everything by r. So we get r squared is equal to negative 6r cosine theta plus 2r sine theta. So now once I have that, I can say that this is negative 6x plus 2y, and r squared is x squared plus y squared. So we can write it like, I'm sorry, that would just be 2y. We could write it like that. Now, in your answer, it completes the square for it. So what it did was it said x squared plus 6x plus some number plus y squared. This is an equal to sign. Minus 2y plus some number is equal to some number. So to complete the square, what can I divide? I'm going to divide 6 by 2 and then square it, so I get 9. I divide negative 2 by 1 and get 1. And so since I added 9 here and I added 1 here, I have to add them both onto the other side. So I get x plus 3 squared plus y minus 1 squared equals 10. And that's how they get the answer in your book. Alrighty, so I want you now to do the even problems. Okie dokie? Alrighty, boys and girls. I'll be back with on how to graph